Hiya, in this video we're going to look at interpreting quadratic graphs. So the lesson intention is to be able to find the coordinates of all the key features in a quadratic graph mathematically. So that will be the roots, the y-intercept, the turning point and the line of symmetry. So for any quadratic, I have labelled all these important points that they ask you about A, B, C, D. Now they don't always ask them all unless they're asking you to sketch it. But they quite often maybe ask for where it cuts the x-axis, where it cuts the y-axis, and the wording might always be different. They won't always clearly say the y-intercept. And sometimes for the turning point, which I've labelled as C, doesn't actually ask you for the turning point, it might ask you for the maximum value. So the graph could talk about throwing a rocket in the air and it could say what's the maximum height. That's them looking for the y-coordinate of the turning point. So there's all these different things to be aware of, but it's very rare for them to be asking you all of them from the one graph. So for all of these, just to remind you how to find them all. So for A and B are called your roots, okay? So A and B are your roots. They both have the coordinate of along something up nothing. So they have an x coordinate, but they don't have a y-coordinate, so their y-coordinate is 0. Therefore, we put y equals 0 into our equation. So you will be given your equation in the form y equals something x squared plus a bx plus c, right? So you'll have some kind of quadratic, and what you'll do is you'll put y equal to 0 and then factorise. Now remember, factorising could be a trinomial, a difference of two squares, or as simple as a common factor. So for the roots, you're setting y equal to 0 and factorising. C is your turning point. Now there are two ways to get your turning point. For all my examples though, if you're finding the roots, we are going to find the middle of the roots, and then that'll give us our x coordinate to then sub in and get our y coordinate. The other option is to complete the square, and completing the square will give you the turning point, but that's a completely different video, and the format I'm giving the questions to you in is probably going to be done through factorising and finding the middle. And then the last bit to ask for the y-intercept, please remember the y-intercept, anything here on the y-axis, has no x-coordinate, so it's 0 something. That's why we can set in x is 0. So a lot of quadratics is just about subbing in. It's either putting x is 0, y is 0. Okay, so we're going to look at some of these, and all I'm giving you is the equation, and we're going to be able to find all these different key features from there. So let's look at question 1. So we have the equation x squared minus 6x plus 8. So it's clearly a trinomial. So to get the roots, we are going to put y equal to 0. So we're going to have x squared minus 6x plus 8 equals 0. Now factorise that goes into two brackets with an x and an x. Numbers that multiply to 8, we could use 2 and 4. To get minus 6, that would have to be both negative. So negative 2 and negative 4. You then solve each of these equal to 0. And that gives you x equals 2, x equals 4. Now that matches the picture. A and B are both positive numbers. So A would be the first one. So A is 2, 0. And B is 4, 0. So that's me got the roots. The second part was to get your turning point. Now your turning point, bang in the middle of 2 and 4. If that's 2 and that's 4, then your turning point would be at 3. So I know my x coordinate is 3. So I replace x with 3. So I'm going to sub in x equals 3 to the equation. So y would be 3 squared minus 6 times 3 plus 8. And that would be 9 take away 18 plus 8. That would give me minus 1. And again, minus 1 matches my picture. It is a negative number. So my turning point, which is C, would be 3, negative 1. Now there's just one last thing to get. The last thing to get is D. So D is my y-intercept. So the y-intercept, remember your y-intercept is always 0 something. So we're going to replace x with 0. So y would be 0 squared minus 6 times 0 plus 8, putting that back into the original equation. Now they all just become zeros, so it's 8. So my y-intercept, which I've called coordinate D, would be 0, 8. Now if I just take you back up to the original equation, the y-intercept is actually the easiest bit to get, look. The y-intercept is just always a numerical bit on the end of the equation, because if all the x's become zeros, it's just a number that is left at the end. So the y-intercept is 8. So that's all the key things we're after. Now there's one more thing I mentioned that we're going to just write in as extra. We're going to write in the equation of the axis of symmetry. So I'm going to call it LOS for short. So my line of symmetry is always x equals, now it's a line of symmetry that goes right through your turning point. Now my turning point was at 3, so my line of symmetry is x equals 3. And then this is literally what we have to do for each question. That will be what our answers are. A and B are your roots, C is your turning point, D is your y-intercept, and our line of symmetry equation. So let's do this again for another one. Okay, so this equation, we've got a maximum turning point, therefore it's got a negative x squared. Now, I don't know about you, but I don't actually teach how to factorise negative x squared, but I do pretend as if we're taking everything to the other side, so it'll become positive. So for your roots, remember that was putting y equal to 0 and factorising. So if y is 0, I can move everything over. So that would become positive x squared, negative 2x, and minus 15. Put it into your two brackets. Numbers that multiply to 15 are 3 and 5. They also make minus 2, but the negative will be with a 5. You then solve both of them equal to 0. And that gives us x equals minus 3, x equals 5, which again matches picture. So A is the coordinate minus 3, 0. B is the coordinate 5, 0. So that's us found our roots. So that's the roots. Next up, we are going to get the turning point. So the turning point happens right in the middle of minus 3 and 5. Now see if you're struggling to find the middle number between 3 and 5. The other option is you do minus 3 plus 5, right? So let me do this up here. So minus 3 plus 5 is 2, and then you half that, and it gives you 1. And 1 is, in fact, in the middle. It's 4 away from each of those numbers. So remember, to find the middle, you can add in half as well. So anyway, x is 1. So turning point is 1 something. That means we can replace x with the number 1. So y would become 15 plus 2 times 1 minus 1 squared, which is 15 plus 2, take away 1, which is 16. So my turning point is 116. So I'm just going to write this over here so all my answers are together. So my turning point is 116. And again, that matches my picture. Look, it's a positive turning point, 116. If your numbers didn't match the picture, then have a wee bit of a check of what you've done. So that's just got my turning point. The last thing to do is get D, my y-intercept. Now, remember what I said in the last example? Your y-intercept is literally the numerical part of y. So to get the y-intercept, remember that is going to be 0 something. So you sub 0 into your original equation. So that would give you 15 plus 0 minus 0, which is just the 15. So remember I just said it was this number part for your y-intercept. So the y-intercept is 0, 15, again matching the picture. So there is all the information we are required. Now again, I forgot that last wee bit. As I said, we were going to do the line of symmetry of them all. So the equation of the line of symmetry runs right down here through your turning point, through the number 1. So your line of symmetry is x equals 1. So I've shown you a quadratic with a maximum, a quadratic with a minimum. Now I'm going to look at one that's not a trinomial, okay? So this one here is just going to be a common factor when we factorise it. So to get the roots, remember that's when you put y equal to 0. So we have x squared plus 8x equals 0. Common factor here of x leaves you with x bracket x plus 8 equals 0. So if you split that up, you have x is 0 and x plus 8 is 0, therefore x is negative 8. Now if you look at your picture, there's your negative 8, there's your 0. So A is negative 8, 0, and B is just 0, 0. So your y-intercept this time is also one of your roots. So you'll notice that's why I haven't put in a D there as well. So your y-intercept and B are the same. So I'm just going to put that in there as well just now. My y-intercept is 0, 0. Okay, the next thing I had to do was get my turning point. So my turning point is bang in the middle of 0 and minus 8. It's a pretty obvious one, isn't it? It's minus 4. So I'm going to sub minus 4 into the equation. So I've got minus 4 squared plus 8 times minus 4. Now minus 4 squared is 16. 8 times negative 4 gives you negative 32. 16 take away 32 is minus 16, which matches my picture. So my turning point C is negative 4, negative 16. So I've already said my y-intercept was the same as my root, so I've already got that there. The last thing to do was to get my equation of my line of symmetry. Line of symmetry ran right down through your turning point, which remember was -4. So your line of symmetry is x equals -4. Okay, so my last example is the last style. This is going to be a wee difference of two squares one. So yet again, we're going to start off getting our roots. So our roots are when y equals 0. So we put 32, take away 2x squared equals 0. There's two ways to go with this. I'll show you them both, okay? So first thing is, oh, there's a common factor. Remember, we're meant to be factorising here. So common factor leaves you with 16 minus x squared equals 0. And then that becomes a 4 minus x, 4 plus x, because they are both square terms. And then from there, you split that up and you get x equals 4 and x equals -4. So there's your -4 and there's your 4. So this is actually a symmetrical quadratic. Now, I did say there was another way to go. So some people might prefer just from here, in this case, to say, right, well, that's 32 equals 2x squared. Divide by 2 gives you 16 equals x squared. So x is the square root of 16. So x equals 4. But square root of 16 only gives you one answer. So if you're going to do this method, be doubly sure that you remember there should be two answers for your roots. And the answers for the roots are 4 and -4, because the square root of 16 could be plus or -4. Okay? I don't particularly like that way, but I know a lot of people do it. But remember, we are factorising, so difference of two squares gets you the two answers straight away. So that makes A is the negative one, so A is -4, 0, and B is 4, 0. Right, my turning point happens right in the middle of -4 and 4, so my turning point is 0 something. So my turning point is also my y-intercept. When you plug 0 into the equation, you have 32, take away 2 times 0, which is 0, so you just have y equals 32. And remember what I keep saying, the y-intercept is just the 32. So your turning point is at 0, 32. So your turning point, which I keep calling C, is 0, 32. That's also your y-intercept, 0, 32. And then the line of symmetry is simply, it's your axis. It is your y-axis. It runs right down the middle. So that as an equation is when your x-coordinate is 0. So when x is 0. And again, that is all the information we are after all in one go there. Okay. So what I've got is I've got 6 here that you can try for yourself. And I've followed a similar pattern. I've got 2 smiley faces, 2 sad faces, a wee common factor and a difference of 2 squares for you to try. And then unpause if you want. The answers are on the next slide. And I'm hoping I've got them 100% correct today. Thanks very much. There are your answers. And for this one, I didn't call it C and D. I started to just write turning point and y-intercept. Because remember, in an exam, they probably will call them the roots, the y-intercept, the turning point. So I'm trying to get that language in there. And remember, I want the line of symmetry for each one as well. Thank you.